Alright, continuing on to this beginning of Algebra 2 lessons, we're going to be moving on into solving inequalities, which is very similar to solving equalities, except we're going to be using inequality signs, less than, greater than, less than or equal to, greater than or equal to signs. But the process is still the same. There's one small difference, and we're going to get to that, and then we're going to deal with and or statements. So the first things first is, if you have something like this, you're going to do the exact same process that you did for solving an equation. Same thing, everything's the same. So again, we want to move this 12 to the other side, so we're going to add 12 to both sides, giving you 3x is less than 15. So you're still treating it like it's an equal sign. And then after that, you divide both sides by 3, giving you x is less than 5. And that would be your answer. Now on top of this, besides just solving it, which this would be fine for just solving it, you're going to also have to graph it. Now when you graph it, there's a couple things you look at. When you make your number line, you do your 0 and mark out all your numbers. At this number, whatever it is less than or equal to or greater than or equal to, you're going to put either an open or a closed circle. If it's not equal to, so like this one, how it's just a less than sign, you're going to have an open circle. So we have an open circle, and then we're saying x is less than 5. So we're going to draw an arrow or shade the region that's all the numbers less than 5, which is why we're going this direction. Okay. As you see, it's an open circle because it's not equal to, we're not including 5, we're saying it goes up to 5, but it's everything less than 5. Okay, so that would be graphing these. So now this problem, exactly the same thing, right? This time I'm going to be multiplying number into both parts. Okay, so I'm going to be multiplying the 5 in. So that gets us a 6 plus 10 minus 5x is less than or equal to 41. Okay. Now we combine like terms, 16, move them to the other side. So we're going to subtract 16 on both sides, and that gets us a negative 5x is less than or equal to 25. Is it 25? Yeah, 25. It's less than or equal to 25. And so now what we're going to do is that we're going to divide by negative 5, divide by negative 5. Now, here's the one main rule that you have with these, is that when you're dividing by negative 5, okay, so when you divide by negative 5, or you divide by a negative number, okay, or multiply by a negative fraction, when you divide by a negative number, you're going to be changing that sign. You flip it to the other side. So that's why we come up with our answer of x is greater than or equal to negative 5. We divided both sides by negative 5, changed the sign. So as you see, we changed the sign going from that second to last step to the last step. And now graphing this one, again, we have our number line, there's our 0, we mark out to negative 5, we close the circle, and then we arrow it, so it's, if you were to read this, this would be x is greater than or equal to negative 5. Okay. So greater than or equal to negative 5. So we're going to shade all the numbers that are greater than negative 5, which would be there. All right. Now sometimes we have stuff that is considered all solutions or no solutions. So we're going to be looking at that. So here's an example of something that has all solutions. So once we multiply this through, so multiply the 2 in, so we'd end up having 2x minus 10. Move the 2x to the other side, get you a 0x. And then move this 3 to the other side, get you a negative 7, which gets you something that looks like this. So after we solve it all the way down, we get x is greater than negative 7. Now since this is a true statement, as you see, we have no x. So if your x disappears or your variable disappears, if it disappears and you end up with a true statement, 0 is greater than negative 7. Okay, 0 is a bigger number if you compare them. Since it's true, all solutions work. No matter what number we plug into x, it will always come up true. This statement will always be true. And so that's what we are doing here. We're showing that it's all solutions. So every single possible number we plug in will work. So we would say all solutions because this last statement, where there's no variables, is a true statement. Now, for thinking all solutions are when you have a true statement. Obviously, the opposite side, if you have no solutions, that means you have a false statement. Here would be an example of a false statement. Again, if we go through and solve this all the way through, we see the x's disappear, or our variable, no matter what the letter is, disappears. And when it disappears, we got 6 is less than negative 28. Well, no, 6 is actually greater than negative 28. So since this is not true, since that's not true, okay, it's a false statement, which means we have no solution. So no number we plug in will make this statement true. Okay, so no matter what we plug in, it will never work out. Okay. All right, compound. So now we have compound inequalities, and we have an and/or statement. So the first one is an and. So again, when you have an and statement, basically what it is, we have two inequalities connected with an and or an or statement. Looking at an and, you solve it the same way. You're going to solve each of these going down all the way to the bottom. Okay. So again, solve for x for both of these. We get x is greater than negative 9 and x is less than 6. So now what we're going to do is that we're going to graph both parts. 0, negative 9, 6. Okay. So now we're going to graph each part. So the first one, we say x is greater than negative 9. So it's an open circle going this direction. And then we also have 6, or x is less than 6. So it's an open circle going this direction. Right. Now, in an and statement, you're looking for where they cross. Okay. Where they cross is your answer. So as we see, I'm going to do this in purple, as we see, from here to here, they intersect each other, which means any number between negative 9 and 6 can work and agree with both those statements. We want a number that works for the first statement, for this statement, and this statement. So it's got to work with both. That's an and statement. So when you graph them, you're looking for the intersection. Now an or statement, you just want one of them to work. It doesn't matter which one, you just want one of them. Okay. Now one thing else with an and, this one can have a no solution. Okay. So you can have a no solution in an and statement. An or statement, you will more than likely always have an answer. Okay. So what you'll do here is that you'll go through and solve it all the way through. Okay. So you solve it all the way through, we get those two. And what we have is with an or statement, okay, when you graph it, so we have 0, and then we have 4 and 5. Okay. And since they're both going to be open circles, the 4, x is less than 4, going this direction, and x is greater than 5, so going this direction. This would be your answer. So any number less than 4 or any number greater than 5 will work for both of these. Okay, for either of them. And that's what an or statement is. We want one of them to work. Okay. Now, the one thing here is that we can have all solutions. So if you do have it, if we have, let's say this is negative 2 and this is 3, if you have some situation where they intersect each other, this is an all solution. Okay, or all real number. Okay. That's how an or statement can be all, is if they intersect each other. If they don't, you just take however the graph gives it for an or statement. An and statement needs the intersection, an or statement does not. Okay, here's your IRAT. So I need you to graph or solve and graph each of these. So the first two you just solve and then graph it on a single number line. Please have a separate number line for each one of these, and then the bottom two is an and and or statement. So you got to see an and, does it intersect, and an or you just graph and see is it an all solution or if it's not. Okay. So please have those done when you come into class.